Hello girls, today we are going to have final revision for Unit 1, Force and Motion. First we must remember the types of levers. We have three types of levers which are the first class lever, the second class lever, the third class lever. Here is the definition of each of them. The first class lever is the lever that has the fulcrum between the effort force and the resistance. The second class lever is the lever that has the resistance between the fulcrum and the effort force. The third class lever is the lever that has the effort force between the fulcrum and the resistance. Now we are going to talk about the conservation of effort for each of them. The first class lever, some of them conserve effort, but the others don't. The second class lever, it always conserves effort. The third class lever, it doesn't conserve effort at all. And now here are some examples for each of them. The first class lever, scissors, crowbar, pillars, nail clipper, and the pedal and the seesaw. The examples for the second class levers are wheelbarrow, stapler, soda water opener, and the nutcracker. Examples for third class levers: manual broom, hockey bat, fishing hook, tweezers, and coal holder. Now we have very important thing to remember. If we have a lever, as you can see in the figure, we must know the force arm. The force arm is the distance between the force and the fulcrum. And the resistance arm also. It is the distance between the resistance and the fulcrum. Now, let's start our revision by the first question, which is complete the following sentences. 1. The crowbar is considered as a first class lever, while the manual broom is considered as a third class lever. I want two examples for the second class levers: the wheelbarrow and the stapler, for example. 3. The law of levers states that, can you remember the law of levers? Force times its arm equals resistance times its arm. 4. The type of levers that always conserve effort is the second class levers, while the lever that doesn't conserve effort is the third class lever. 5. There is a conservation of effort in the first class lever if the force arm is longer than the resistance arm. 6. The manual broom is an example of the third class lever. 7. Dots is considered as one of the first simple machines which is invented in the past. Of course, the levers. This is the definition of the lever. 8. The lever is a dot that rotates around a fixed point. Of course, it's a rigid bar that rotates around a fixed point. 9. Scissors are considered from the first class levers, while a fish hook is considered as a third class lever. 10. Force arm is sometimes equal to the resistance arm only in the first class levers. 11. Force times its arm equals resistance times its arm. 12. The nutcracker is considered as a second class lever. 13. Dots is a lever from the third class, for example, a coal holder. 14. When the force arm is shorter than the resistance arm, so the effort force is larger than the resistance. Now it's time for the second question, which is write the scientific term. 1. Levers that always conserve effort. Second class levers. 2. Levers that don't conserve effort. Third class levers. 3. Levers that sometimes conserve effort. First class levers. 4. The fixed point that a rigid bar sets on. It's the fulcrum. 5. A rigid bar rotates around a fixed point called fulcrum and is affected by force and resistance. It's the lever. 6. The simple machines act as effort-saving. Lever. 7. Levers in which the resistance is found between the fulcrum and the effort force. Second class levers. 8. Force times its arm equals resistance times its arm. It's the law of levers, of course. 9. A fixed point at which a solid bar is placed. The fulcrum. Now we came to the most important question. It's solve these problems. Solving problems is very, very important. When we have a problem in the exam, first we must write the rule. Then reading the question and getting out all the given. The force is 100 times its arm, which is 25, equals the resistance, which is 500, times the unknown, which is the resistance arm. By solving the problem, we will find that the resistance arm equals 100 times 25 over 500 equals 25 centimeter. Similarly, we are going to solve the second question by writing the rule at the first, then finding all the given. The force is 8 times its arm, which is the unknown, equals the resistance, which is 4, times its arm, which is 2. So, by solving the problem, we will find that the force arm equals 4 times 2 over 8 equals 1 centimeter. Thank you, girls, for listening.